Hello everyone, welcome to my another video. Now in the last lecture we talked about what is linear regression. We saw how to use the least square method to find the best fit line and what were the applications of linear regression. Now in this video we are going to talk about what are the losses in linear regression. So when we talk about loss, it is actually a numerical metric that describes how wrong a model predictions are. Now in general machine learning sense, we say that loss is actually the difference between actual minus predicted value. Now in this figure you can see there are multiple data points and each distance of them represents the loss. So this distance is actually representing my loss. So as the distance is more, the loss is more, and as the distance is less, the loss is less. Now for instance, this data point has the least loss as compared to other data points. Significantly, these two have lesser losses, whereas the maximum loss is incurred by this point as the distance is maximum between the best fit line and this particular point. So the goal of any machine learning model is actually to minimize the loss and improvise its accuracy. So the accuracy must be maximized and the loss must be minimized. Now in this figure, we can visualize the loss as arrows drawn from the data points to the model, and the arrow shows how far the model predictions are from the actual values. Now let's talk about the distance of the loss. So the distance of loss is actually actual minus predicted values. So as distance could not be negative, so there are two methods through which we actually make the distance positive. First thing is we take the absolute values of actual minus predicted values, and second thing is we do squaring of actual minus positive values. Now for instance, let's say absolute value of minus 3 is 3, and if we have actual value as my 3 and my predicted value as 4, then the result is minus 1. Now if we square this, we get 1. Now let's talk about types of loss. So in linear regression, there are four types of losses which we need to know. The first thing is the L1 loss. So L1 loss is actually the summation of actual minus predicted values. So as we take the absolute value of them, the resultant is always positive value. Second thing we need to know is the mean absolute error. Mean absolute error is actually the average of L1 loss across a set of samples. So it can be characterized by the formula 1 by n summation of a minus b, which is the actual minus predicted values. Again, you can see the distance is positive in this case too. Now let's talk about third type of loss, which is also called as L2 loss. Now L2 loss is actually the sum of squared of a difference between the predicted values and the actual values. So we can characterize this using the equation summation of actual minus predicted whole squared. And let's talk about the final type of loss, which is also called as mean squared loss, which we will be seeing in upcoming algorithms also. Sorry, it is also called mean squared error. So 1 by n is summation of actual minus predicted whole squared. Now this can be said as average of L2 losses across a set of samples. Now let's talk about how do we choose an appropriate loss function for our linear regression model. Now deciding whether to use mean absolute error or mean squared error can depend entirely on our dataset and the way we want to handle certain predictions. Now before understanding which loss function should we choose, let's understand what is outliers. So an outlier can also refer to how far off a model predictions are from the real values. Now in this figure you can see these are my outliers as these are far away from my real predictions. And in this figure you can say that these are my outliers. Now in choosing the best loss function, we want to consider how the model wants to treat the outliers. Now for instance, MSE actually moves the model more towards the outliers while MAE does not. Now L2 loss actually incurs a much higher penalty for an outlier than L1 loss. Now for example, in these images, you can see that the outliers are closer to the model trained with MSE than to the model trained with MAE. Therefore, you can say that a model trained with MSE moves the model closer to the outliers, and the model trained with MA is farther away from the outliers. So MSE actually moves the model closer to the outlier. Whereas mean absolute error is taking the model away from the outlier. Now let's see an interactive exercise where we can see how we can adjust the parameters of linear regression so that the best fit line changes accordingly. Now as I said that these weights are actually my slope of the line, and the bias actually represents the y-intercept. Now let's change the slope of the line and then monitor the losses in the right side. As you can see, if I'm changing my slope, the losses are actually increasing. If I'm decreasing my slope in the proper way, you can see that my losses are actually decreasing in the sense. Now as I again move it towards the backside, the losses are again increased. Now the distance between these lines and the point should be minimum. Therefore, you can see that the loss is now minimum, and this bias actually represents the y-intercept. So let's play with this also. Now if you see that if I'm decreasing my y-intercept, losses are gradually increasing. Now if I adjust it accordingly, the losses will actually decrease. So that is how you can monitor the weights and biases which are actually my slope and the y-intercept, so as to change the best fit line and then monitor the losses accordingly.